All right, hi guys. We're continuing with our topic of hydrology. So this is like kind of a continuation of infiltration notes, talking about porosity and permeability and all that stuff. But we're going to focus on something called groundwater. So these are the notes that you can find online. They're under the class documents under Unit 6 notes. So you can find those notes there. That's the PowerPoint I'm going to go through. There's also these two things. This was a picture that I had drawn. This is just a little bit cleaned up version of it. Either one is going to bring you to a document. It looks like this. It's a little bit whited out, but it will work if you want to use that. I'll print it and color it. That might be something fun to do. Okay, so in your notes, I'm going to go through this PowerPoint together with you. Once you've printed off that sheet of paper, you're going to come to a picture that looks like this, and we're going to go through all these letters and what they are, A, B, C, D, and you guys can fill that out accordingly. If you want to, you don't have to do that, but it's something that might be nice to get some of these terms inside of your head. And this picture I actually sketched from this picture here. Okay, so you have all the same letters drawn on this. This is just a colored version of it. Heck, if you want to like color this thing up and send me a picture of what you colored, that'd be cool to see what you guys can draw. But this is what we're looking at here. So I'm going to actually use my picture, and we'll go through each one of these letters individually. So this area, this is the surface. This is like a hillside. And as you can see below the ground here in this area called A is something called the unsaturated zone. So the unsaturated zone is this area below our feet that is essentially just, soil and rock that is not saturated. So it's like a dry sponge. And the area in between all the particles, all this pore space, that would be dry or filled with air. So it's called the zone of, or the unsaturated zone, also known as the zone of aeration. So it's aerated, meaning there's air in between the particles. Okay. B, this area down here is below what we call the water table, and this is the saturated zone. So this is completely filled in with water. It's kind of like the lab that you guys were doing yesterday. It's the area below the water line. And so all the space in between the pores is completely filled in with water. And so it's the zone of saturation, or the saturated zone. C is the line that separates A and B. C is called the water table. It's the top of the saturated zone, or the bottom of the unsaturated zone. And the water table can rise and fall depending upon how much rain is falling from the sky. Okay. D is a well. And as you can see, this well goes down into the ground. We're going to talk about wells later. The well doesn't go very far down. It's actually in the unsaturated zone. So this well is actually not working. But that is a well. E is a well that is working. Okay, so you could say this is a non-working well. E is a working well. It's actually pumping out water. F is this area that's below the ground that is saturated. It's kind of like this picture here, so you can see it's this area. And F is what we call an aquifer, A-Q-U-I-F-E-R. So aquifer. An aquifer is an area of groundwater. It's kind of like this area. But this one is perched on top of this layer here that's actually referring to, that's G. G is referring to what's called an aquitard. So A-Q-U-T-A-R-D. Aquitard is just typically a layer of bedrock that is blocking the water from going down any lower. So it stops the water from going down any lower. And you can see it here. That's bedrock that's below the ground. The water can't go any lower than that. So that's called an aquitard. Okay. H is this little stream that's coming out of the hill. That's called a groundwater spring, or you can just write spring if you want to for H. A spring is water that seeps out of the ground. I'll show you a video of that later on. And then I is just our stream. Okay. Now, one thing I'd like you to notice, and we'll look at this later on, the water table line and the level of the stream are the same thing. So that's kind of interesting. Okay. So what is groundwater? Where is groundwater? There's a video here. I'm going to link this onto the daily agenda if you want to take a look at that. It might be a worthwhile watch, but I'm not going to play it here. But groundwater is essentially all the water that is pulled down by gravity. It infiltrates through the surface and fills up all the spaces in between the soil and in between the rock, filling up all the pore space. So groundwater is just referring to water below the ground, hence the name. And the groundwater is actually a really important resource, which we're going to look at a little bit later on. So this diagram actually shows, again, the unsaturated zone, the saturated zone. The water table is the line between them, and you can see where the water table reaches the surface water of the lake here. Okay. Now, these are just definitions of those words that are from before. So the zone of saturation is below the water table. The zone of aeration, or the unsaturated zone, is above the water table, and the water table is just that line that separates it. Now, the cool thing about the water table is that this line can go up and it can go down. So when it's going up, this water table is rising. We have more water below the ground. That's typically when it's been raining for a number of days, kind of like outside, okay? The water table is really, really high, and the ground is completely saturated, and you step around in your backyard or your front yard, and it's all like sopping wet, okay, like my backyard right now. Now, the water table can fall when it's not raining as much, when there's not as much water infiltrating into the ground, and the ground is really dry, and that's typically in the summertime. Okay, so this water table can go up and it can go down depending upon what's happening at the surface. Okay, so you can see this diagram actually shows all the same stuff. Please notice that the water table, or sorry, the saturated zone, this area here, the zone of saturation, can go down pretty far below the ground, but usually there's some kind of barrier below them that's preventing it from going any lower, and that's typically bedrock. Okay? Now, interesting thing about groundwater, which you might learn about later on in life. Oceans, which we'll talk about later on, move at a pace of about a walking speed, somewhere in the 2 to 5 mile per hour range. So if you get in the ocean, you'll get moved across the ocean. If you're in a raft without a sail, you'd move across the ocean pretty slowly. Okay, so pretty slow for oceans. A steep river and like mountains might be going like 20 miles an hour, 30 kilometers per hour. So pretty quick, like whitewater rafting kind of stuff. But groundwater below our feet, it does move, but it moves at a super slow pace. And you can see that here, 0.00002 kilometers per hour. So that's like ridiculously slow. And that's because it's got to percolate. It's got to move through all these little tiny gaps underground. And so it has to kind of squeeze its way through, and that's really difficult for water to do that. So that's why it's moving at a slow pace, which can be a good thing and a bad thing. And maybe we'll talk about that later. Okay, so here's why groundwater is important. In the United States, and this is 2005, so it's a little dated, but you can see on this graph, most of the water that we use from groundwater reservoirs is used for irrigation, for our crops, for farmland. And that's typically out in the Midwest. They're pulling a lot of water from what's called the Ogallala Groundwater Aquifer, and all that water is used to irrigate the crops, which then feeds America. So irrigation is the big thing. Okay, we're pulling the water out of the ground for that purpose. After that, it's for public supply. So you may or may not live in the country, and if you do, outside of the city water that you might get, like I get city water, but if you live out a little bit further out into the country, you're probably pulling your water out of the ground. That's where I grew up. I had groundwater, and the groundwater was used for everything in our house, so drinking, bathing, etc. Okay, and a lot of people in the United States get their water from the ground. I'm going to skip over this stuff, and I just want to talk a little bit about groundwater contamination. Maybe we'll talk about separately, but I just want to take a look at like what you perceive and what's actually reality. So if you take a look at this picture, a lot of Americans, and maybe even students in general, perceive groundwater to be this like open cavern underground that's filled up with water, and you like stick a straw into it and suck it out of the ground. Like that's what a well does. Not at all. Okay, we're not pulling the water out of the ground from some open cavity underground that's filled up with water like this picture is showing here. This underwater cave here is a pretty rare circumstance. Okay, yes, that can exist, but no, that's not everywhere. Okay, so just a heads up, this is maybe your perception of what groundwater is, but that's not reality. Now, we have been pulling water out of the ground for a very long time, and ancient wells you can find pretty much all over the world. This is probably an image in your mind of what a well is. Okay, and that's definitely true. This is a well. What did they do to make this well? They had to dig a hole down underground, probably about 20 feet down. They lined the whole entire hole around the outside of that hole with rocks so it wouldn't cave in, built it all the way up to the surface, and then the water kind of seeps into the bottom of that well, that bottom of that hole in the ground. And so you just dip a bucket down into this open cavity underground. Now, that's not how most people get their groundwater nowadays. If I had to live like that when I was growing up, that'd be a pain in the neck if I had to, lower a bucket down to take a shower every time I wanted to take a shower or wanted to have drinking water. Some people have to do that, and it is a lot of work. Nowadays, we drill wells underground that are pretty deep, and we drop a pump down to the bottom of the thing and pump the water out of the ground up a pipe into your house. Okay, and the process behind this whole groundwater well drilling is actually really interesting. I watched a video earlier that I'll show to you. I'm not going to play any of it, but I just want to show you guys the actual. Well, hold on, let me find it here. Oh, there it is. Okay, this video here. Maybe I'll link to this. It's 17 minutes long. This guy goes through how groundwater comes out of the ground and how they drill the well. And it's kind of interesting. So, and the guy kind of looks like me, so that's kind of weird. But anyway, it'd be a worthwhile watch if you want to know a little bit more about how we get the water out of the ground. So, I'm going to stop there. I covered the basics of groundwater. We'll get into some other details of things later on. I want to show you guys some stuff outside. So one big takeaway, I'll review this one more time again. Okay, and I'm going to use this picture this time. So again, this area down here is called the zone of saturation, or the saturated zone. That's where all the groundwater is located, in between the particles of underground, and between the soil and between the rock, any crevices, filling it up completely saturated. This is the unsaturated or aeration zone. This is an unsuccessful well because they didn't drill it down into the groundwater. This is a successful well because they drilled into an aquifer. They got lucky. This aquifer is exactly like down here, but it's perched on top of this thing called an aquitard. It's just a layer of bedrock that stops the water going any lower. This is a spring, which I'll show you a video of. This is called the Groundwater Spring. I'm at Baltimore Woods, and this water is just coming right out of the ground and trickles right down through this valley and down that way. This layer right here is the water table. Okay. Now, one thing I didn't mention, and I should probably go back and just point this out. If the water table rises, that would be when it's really rainy. Well, that means this whole entire line is coming up. And so the water table, where the stream level is, also rises. So the stream fills up too. It floods its banks. Okay, so I might have to draw a diagram of that to make a little bit more sense. All right, guys, I just want to show you the idea that the water table affects the surface water. So if this water table rises, the surface water rises because it's the same line. If the water table drops, then the surface water drops. And you can see the same thing here. The water table line is the river line, or the level of the river, or the level of a lake. And if that river is dropping, it's because the water table is dropping. Now, what would make that water table drop? It would be when it's dry, when there's less rain, when there's less snow melt, like the middle of the summer. If the water table is rising and the river is rising and flooding its banks, that's when there's a lot of rain and there's less of an unsaturated zone. There's more of a saturated zone below the ground, kind of like what's going on right now. So you can see this winter water table when the river is high, that's when there's a lot of snow melt, more of a spring water table. Okay. In the summer, that water table drops, and now we have a water table down here, and the river basically dries up. So that kind of explains that section and that idea, and that's something that will definitely get asked. Okay, so that's pretty much it. Hope you guys understand all that, and if you have any questions, let me know.